Hello, my name is Julia, and this is Space Daily News channel. NASA's newest flagship telescope, the James Webb Telescope, is less than a year into its science mission, and NASA is already hard at work building the next generation of telescopes. In November 2021, the US National Academy of Sciences recommended that NASA astrophysics focus their efforts on the Nancy Grace Roman Space Telescope, slated for launch in the mid-2020s, and on the next flagship astrophysics mission, which should be a space telescope operating in the infrared, optical and ultraviolet bands that can search for habitable exoplanets and signs of life on them. During a presentation on January 9, NASA presented the first data on the telescope. So far it has been named the Habitable Exoplanet Observatory, or HabEx. It will be a space telescope with a monolithic primary mirror 4 meters in diameter, equipped with a coronograph, a tool that allows scientists to study faint objects near bright stars. Also aboard the telescope will be a UV spectrograph and a wide field of view camera. But perhaps the most unusual solution will be the use of a huge star shield that will be paired with the telescope, but from 69,000 to 186,000 kilometers away. This star shield, 72 meters in diameter, will be a technically complex space-deployable structure whose job is to block the light from a star, allowing the telescope to see planets near it. The frame of the shield is supposed to be made of thermostable carbon fiber, the petals of opaque kapton. The HabEx telescope, like James Webb Space Telescope, is planned to be launched into a halo orbit at Lagrangian point 2 of the Earth-Sun system. But unlike James Webb, the future observatory will have a robotic upgrade capability. To launch the new telescope, it is planned to use rockets with a large fairing. For example, Blue Origin's New Glenn rocket, which the company claims will have a 23-foot wide fairing, or SpaceX Starship, which has a diameter of 30 feet, or the Space Launch System rocket in configuration 1B with an 8.4-meter diameter fairing. The HabEx observatory is expected to provide direct images of planetary systems around stars similar to the Sun. HabEx will be sensitive to all types of planets, but its main goal is to obtain for the first time direct images of exoplanets like Earth, and to characterize the content of their atmospheres. By measuring the spectra of these planets, HabEx will look for signs of their suitability for life, such as the presence of water, oxygen or ozone. In addition to searching for life on exoplanets, HabEx will enable a wide range of general astrophysical studies, from studying the earliest eras of the universe's history to understanding the life cycle and demise of the most massive stars, which ultimately supply the elements necessary to sustain life as we know it. Space Daily News. Like, share and subscribe.